right, good morning. Today we're going to talk about arc length and sector area. And I kind of wrote out all the notes outlined to begin with, just because it was a lot to write and I didn't want you to have to wait for me. So for you to write this part, you may want to pause the video, write it, and then fill it in with me. That's up to you. But I'm just going to go from here as if you already have it written, but knowing you can pause the video at any time. So the first thing is we're going to be talking about arc length and sector area, and I'll kind of describe more what those are and what they look like here. But you might remember from the other day that the measure of an angle in radians is equal to the arc length divided by the radius. So remember, the S stood for arc length and the R stands for radius. So the angle here is the same as the arc length S divided by the radius. And I'm going to go ahead and highlight the arc because we're just talking about that piece. You may also remember that 1 radian is when the arc length and the radius are the same. That's 1 radian. So depending on the circle will depend on, whatever, but if the radius was 12 and the arc length was 12, then it would be 1 radian. All right, so what is the formula for arc length? S, arc length, is equal to the radius times the degree in radians. So basically all we did was multiply by r on both sides to get r out of the denominator to get the arc length alone. Arc length we're doing in radians, so you may have to convert degrees to radians. Depending on the problem. All right, so again, arc length is this piece here. How big is that? How long is it? Versus sector area, which is basically talking about the area of a section of the circle. So we're not just looking at the outer edge, we're looking at that whole section there. So the area of the sector is 1/2 the radius squared times the measure in radians. And again, you may have to convert between degrees and radians if you're given information in degrees. So those are the formulas. Let's use them. So whenever you're doing examples, especially when you're using a formula, I always recommend that you write the formula each time. Don't leave off any part of it. So a lot of people like to just write down like this part of it and forget the beginning on the other side of the equal sign. But you need to remember that because sometimes you might actually get this and need to solve for something else. So let's substitute. We want to know the arc length, we have the radius, and we have the measure in radians. So the arc length, for example 1, is 12. And that's really all there is to it. So I would like you to pause the video and do problem number 2, and then unpause and check your answer. All right, welcome back. So we need to write the formula. The radius is 8, and the measure in radians is pi over 12. So we're going to go through and simplify. I like to put my 8 over 1, 4, 3. All right, so the arc length is 2 pi over 3. Now, if we gave you the degree in radians or in degrees instead of in radians, you'd want to convert that first. So we're going to convert 22 to radians. Remember, we want pi in radians, so we're using the one with pi on top, pi over 180. We're going to simplify that. So 11 pi over 90 is the measure of the angle in radians. So we're going to use our formulas. Arc length equals the radius, which is 18, times pi over 90, the measure in radians. And we'll simplify that. 18 goes into 95 times. So the arc length is pi over 5. Sorry, 11 pi over 5. I just totally forgot my 11 right up there. So that's how you find the arc length if you're given the radius and the measure in radians. But like I said, sometimes we're going to want to find a different part. So for this one, we're actually missing the radius. So the question would have said, what's the radius? Same formula, except we know S. And we know the measure in radians. And now we need to solve this for R. So remember, to get rid of a fraction, we're really dividing by it, but you know when you divide fractions, you multiply by the reciprocal. So that's all gone. Pi's are gone. 5's are gone. So the radius of this circle is 2/3. So you can use the same formulas to find all three different things depending on how you manipulate each equation. All right, so pause the video and do number 5. Notice that this is in degrees. So you're going to have to switch from degrees to radians and then use the formula. All right, welcome back. So 45 degrees is, to convert, pi over 180. So pi over 4, which you might remember from the unit circle. Hopefully you do remember that from the unit circle. And truly, you don't need to do this work if you envision the unit circle in your head. But if you don't, then you want to go ahead and do that. And then we're going to solve. S equals the radius times the degree in radian, or measure in radians. We do not know the radius, but we know the arc length. And we know the radius. So hopefully you multiplied by the reciprocal. Gone, gone. So S equals 8 pi over 11. Not S, oh my gosh, R, the radius. All right, so that's how you use the arc length formula. Let's do sector area. Again, I recommend always, trying to get this in here. There we go. I always recommend that you write the formula. So we're going to find the area of the sector. Area equals 1/2 r squared times the measure of the angle in radians. You're not substituting for that r. That one's just telling you that you're finding the degree in, or the measure in radians. It's not the same as this one. All right, we don't know the area. We do know the radius. And we know the measure of the angle in radians. And from there, you just multiply. So I'm going to just use my calculator for right now. 2.2 times 3, oops, is 6.6. So that's going to be on the top. And then 2 times 8 is 16. And we need to simplify this part. So, oh my gosh, guys, I forgot to square this. 2.2 squared is 4.84. So we're doing 1/2 of 4.84 times 3 pi over 8. So 4.84 times 3, 14.52 over 16 with our pi right there. And then I'm going to simplify. So 14.52 divided by 16. In a graphing calculator like this one, you press math, fraction. And did I forget the half? Let's see. 1/2 times 2.2 squared times 3. Oh, I think I forgot the 3. Yes, this is 7.26. Sorry, I'm going to delete this part of the video maybe, but if I'm too lazy to do that, then that's what it is. So It's 4.84 times 3, that's what I think I had forgotten, 14.52 over 16 with the pi. Divide by 16 and simplify. I don't know what in the world I'm doing right now. I mean, I know how to do it. I just keep typing it in wrong. All right, I'm just going to type the entire thing into here. 1/2 times 4.84 times 3 is 7.26 pi over 2 times 8 is 16. And then for this, what we want is the answer as a decimal. So I'm just going to do that. I'm going to get 1.4. No, again. Oh, guys. All right, that's an 8 because I had already multiplied by 1/2. So, excuse me. Okay. Oh, I keep sneezing. Okay. So 7.26 divided by 8 and times pi is 2.9. So that is the area of this one. Now, I'm sorry about all those mistakes. I'm going to try to pull them out before I show you the video. But if I didn't, then really I was just making silly little mistakes. I was typing in 1/2 and then forgetting to square something in the calculator. This is the process. So you substitute in and then you just multiply all that stuff and you get your answer. I apologize for all of my mistakes. However, I'm just a person. So that happens. All right, this one, we're given degrees. So we need to convert this one to radians. 22.8 times pi over 180. So I am doing 22.8 divided by 180, and I'm going to use math fraction to turn that into a fraction without a decimal in it. 19 pi over 150. Then I'm going to use the formula. So area equals 1/2 radius, which is 2.6 squared, times 19 pi over 150. So I'm just going to type this entire thing into the calculator. 1/2 times 2.6 squared times 19 pi over 150. 1.3. 1.35 is the area. All right, so you can see that's really all you have to do. I don't know what was going on with that other one. So that's how you find arc length and sector area. Enjoy.